You're watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. Here's what's coming up this hour. Get more information, special announcements, and weekly program schedules online at wishtv.com, and be sure to follow us on Facebook. Here's what's coming up next.
Hey, fourth graders, it's Mr. Nick from the math department. We're going to do day one, week one from the math packet, except for paper's boring to me, so we're going to have some more fun with it than that. All right, so if you look in there, they say the very first thing you're supposed to do is like measure the width of your bed or the width of a door or the height of the floor to the seat of your favorite chair, length of your telephone or cell phone, dimensions of your favorite book. All of these things, they say measure in centimeters. There's lots of ways that you can measure things in centimeters. So like a ruler, a centimeter cube I hear. Somebody said meter stick. No one said this, but like a pin. A pin is about 15 centimeters. So if you can find a pin around your house to measure some things, maybe 15 centimeters. If you can find, like, go in mom's purse, and if you can find like a dollar bill, that's like 16 centimeters. So we can use that to measure things. Don't really do that. No one needs to get in trouble right now. So since there's no bed in this room here, let's find something that we can measure in here. So let's measure the height of the whiteboard, and I'm gonna measure it with this dollar bill. That's 16 centimeters. So I'm going to start at the bottom and just mark how many there are up. What do you guys think? How much of that dollar? It's right like halfway in George's head. So half of 16, we'll say that is 8 centimeters. From there to there, 16 centimeters. How much here? That's right. How many 16s do I have? 1, 2, 3, 4, 5, 6, 7 16s. 7 groups of 16, and I have one length of about 8 centimeters. Nobody really cares how long this whiteboard is, so we're just gonna get as close as possible. All right, so I'm gonna do this, see if I can do it in my head. 7 times, I'm going to split up 16 into 10 and 6. So I know 7 times 10 is 70, plus 7 times 6 is 42, plus 8, 70 plus 50 is 120 centimeters. All of that measuring done with the dollar bill. So now your job is to measure something more exciting than what it is on the sheet. So if you can find, like, go chase down your dog and measure how long your dog's tail is, or if you want to measure the width of your bed or how long your sister's hair is, any of those things, go measure those things. Just cross out what it says on this piece of paper and go measure that. All right, let's move on to number 2, composite numbers. Now, a little confession, you may or may not know what composite numbers are, because sometimes Indiana moves some things around with what they tell us to teach fourth graders, but I think you can do this. So composite numbers are numbers that have more than 2 factors. So if we think about factors as a factor times a factor equals a product. So if I think of let's do a 2-digit number first. So if I think of like the number 12, what are some factors, what are some numbers that we can multiply together to get the number 12? So one way we can do it is we can do one group of 12. So it has that factors 1 times 12 equals 12. Is there another way that you can make 12? Somebody said 2 times 6. So 2 times 6. So does 12 have more than 2 factors? It has 1 in 12 of its factors. It has 2 in 6 as factors. Is there another way we can make 12? Does 3 times something equal 12? That's right. Somebody said 3 times 4. So 3 times 4 equals 12. So all of the factors for 12 are 1, 2, 3, 4, 6, and 12. That's more than 2 factors. Let's do one that does not have more than 2 factors. So let's try 5. What are some ways you can make 5? Somebody said one group of 5. Is there another way we can do it? That's true, you could do 2 times 2.5 or 2 times 2.2 5/10, but these have to be whole numbers or positive integers in this case. So is there whole numbers without decimals or fractions that we can use to make 5? Or is this the only way? So this is the only way that we can make it. That's a prime number, not a composite number. So here's our goal. Using the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, let's try to make as many composite numbers as possible. So I'm not going to do them all for you. 8. Is there more than one way to make the number 8? You could do 1 times 8. What else? 4 times 2 or 2 times 4. So it has more than 2 factors. That works there. Let's cross out 8. Can you think of another number? 45. And so I'm going to put that in the 2 digits there. That's 45. What are some ways you can make 45? 1 times 45, definitely. Will 2 work? No, because it's an odd number. What about 3? 3 does work, but I want you to figure out with what other factor does 3 work with. And somebody said 9 times 5 would work. So it does have more than 2 factors. The rest of these, you're going to try to figure those out on your own. Remember, you can only use each digit 1 time. Go ahead and try that on your own. All right. Now what I want you guys to do is draw a picture for the story that I'm going to tell you. All right, so think it through real quick. You can even close your eyes, and I'm going to tell you the story. I want you to visualize this story happening. 10 alligators went to the river. Can you picture 10 alligators going to the river? 3 of those 10 alligators laid eggs. Think of that in your head. See the 10 alligators going to the river. 3 of them laid eggs. Each of those 3 laid 5 eggs. Picture how many eggs there are now. How many alligators? 3 of them laid 5 eggs each. And then out of nowhere, a snake came out and it ate 8 of the eggs. Draw a picture in your head right now thinking about that snake eating those eggs. The question that you have to answer is how many eggs are left? You got that all on your own. We'll see you next time, 4th graders.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hey fourth graders, it's Mr. Nick again. We're ready for day 2 of your learning. Take a look at these objects. There's a rectangular prism, looks a little bit like that. You've got a cube, or a picture of a cube, a pyramid that I don't have on here, a cone, a sphere, and a cylinder. And then what they want you to figure out, and this is way too easy for us, they want you to figure out is whether it's rollable or whether it's stackable. Can I roll it or can I stack it? I think that depends on what we decide to do. So we're going to start off with the sphere. Is it rollable? Yes, but I bet I can stack it. See, I did it. So what you're going to do, look at all of these, think about like whether it's rollable and how you know it's rollable, because I bet some of you be like, I could roll this cube. Which one's going to roll further, the sphere or the cube? How about the rectangular prism? What about the cone? What would happen when I try to roll this? Is it going to roll the same way as the sphere? And then what things can I stack? So if I try to stack the cone like this, wow, it won't work. But is there a way that I can make it work? So in your details about when it can be rolled, when it can be stacked, talk about the differences between those times that it can be rolled and it cannot be rolled, or when it's going to roll further as much as possible. And if you can find objects like this around your house, try to figure those, find those and see what you can stack or how high you can stack things on top of each other. Because here, the cylinder, the rectangular prism, the cube, the cone, and now I'll put the sphere on top. That didn't work. All right, but how many things can you stack on top of each other? All right, you guys ready for the second one? All right, it's called the pig game. So pig is a game for 2 or more people. Players take turns rolling one die as many times as they'd like. If you roll a 2, a 3, a 4, a 5, or a 6, the player adds that many points to their score for the turn. A player may choose to end their turn at any time and bank their points. But if you roll a 1, you lose everything that you didn't bank. So you can keep rolling until you roll a 1, or you say, I'm going to bank all of this. Now, if you're like me and you're stuck in a room all by yourself, we're going to have to play a little differently. So my goal is going to be, how high can I roll without getting a 1? So what's the biggest number I can get without getting a 1? All right. Now, I have these big foam dice. If you don't have a die at home, you can take just pieces of paper and write 1, 2, 3, 4, 5, 6 on them, and then just shuffle them and keep them face down to play this game. All right. If you want to play with your dog or your cat, because you don't have a brother or sister, anybody else who wants to play with you right now, you just get to play as your dog and as your cat. All right, you ready to go? So my goal is going to be, how high can I get without getting a 1? So here's my very first roll. I got a 2. So for Mr. Nick, I've got 2. I'm going to roll again. And my goal is to try to get to 50. All right, but if I roll a 1 right now, I'll lose everything. I got a 5. So I got 2 plus 5. My new total is 7. I'm going to roll again. I got another 5. 7 plus 5. My new total is 12. Rolled again. I got a 4. 12 plus 4. So I have them at 16 points. If I were to roll a 1 right now, I'd lose all 16 of those points. Or I can say, I want to bank it, and now it can be my dog's turn. But I'm going to be brave, and I'm going to keep rolling. That was going to fall off the table. I got another 5. 16 plus 5. Now I'm at 21 points. I got a 6. 21 plus 6 equals 27 points. The world deserves to see if I can make it to 50. I got another 5. 27 plus 5 equals 32. I don't hear any of you cheering for me to get to 50. I got another 6. 32 plus 6. I'm at the 38. How much more do I need to do to get to 50 and beat the dog? Oh, so because I didn't bank any of that, I just lost all 38 of my points. I could start, and at any one of these points, I could say I want to bank it. I could have banked it right there when I rolled the 2 in the beginning. All right, that's how you play the game. Play it as much as you'd like. Use your cards if you have to. All right, your very last activity for day 2 is to do same or different. So this is the first time you've done this in the new packet. So we're going to look at these 2 pictures. Uh-oh, that's shaded in on your packet. And we're going to say what's the same about these and what's different. So you're going to make a 2-column chart, and you're going to put across one side same, one side different, or a T-chart, your teacher might call it. So if I look up here, what's the same? There's no wrong or right answers. If you see something that's the same, then you just put that on your paper. So you could say they both have rectangles, and you'd write rectangles. You could say they both have one bar shaded all the way up. You could say whatever you think about that, but they're both horizontal. Anything you can figure out that they're the same, write it down on the side of your chart that says the same. Now, what's different about them? And I'm not going to take any of your ideas away from you, all right? What is different between the top ones and the bottom ones? I probably should have said that clearer in the beginning. But what's different between here and here? And once you have that figured out, just fill it out in your T-chart. What's the same? What's different? No idea is right or wrong. You guys get to just use your own mind. And guess what? If you come back to school and you show this, your paper is going to look a lot different than the person sitting next to you because it's your ideas. And that's what mathematics is about. We'll see you guys tomorrow.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
All right, 4th graders, well, I'm betting it's not just 4th graders now. I'm sure, you know, you've called your friends, you all want to see Mr. Nick, so we're on day 3 now of the packet. So if you don't have the packet, I'm going to try to draw as much for you, all right? I can picture how filled the living rooms are right now because you're that excited to see Mr. Nick. Day 3, grade 4, and the first thing we'll work on is prime numbers. So a couple days ago, we worked with composite numbers. Prime numbers are the numbers that have exactly 2 factors. So let me give us some examples. Let's try the number 7. So remember, factor times factor equals the product. So if I try to find the factors, what are 2 numbers that I can multiply together that give us the product 7? So I'm going to draw an array for this. So one array that I can make is 1 times 7. And that equals 7. So it's 2 factors there are 1 and 7. I can draw another array for this. I could go 7 times 1, but it still has the exact same number of factors, or the exact same factors. 7 and 1 are its only 2 factors. There's no other ways I can multiply whole numbers together and get the product 7. So that makes 7 a prime number. Let's try another number. So we know that 7 is prime. Let's try another number. Can you give me a number? That's too big. I want it to be a 2-digit number. All right. So let's try 16. I'm fine with that. So 16, what are some ways we can make 16? 1 times 1 times 16. Do you see the spaces that I'm putting in as I make it? That's so I don't have to keep count. So I know 5, 10, 15 plus 1 more is 16. So I can do 1 times 16. Is there another way to make 16? I heard you. So you could do 2 times 8 equals 16. So we know that 1 times 16 and 2 times 8 both equals 16. So that has 1 as a factor, 2 as a factor, 8 as a factor, 16 as a factor. Is there another way to make it? That's right. 4 times 4 equals 16. I almost forgot that one, and next time I'm going to leave it out so that you can all yell at the TV that Mr. Nick left out the 4 times 4. All right, so as we do this, is 16 prime or composite? Prime means it has exactly 2 factors. So 16 has way more than 2 factors. That makes it composite. Your goal is to see if you can make, using the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9, 1 time each, can you make a whole bunch of prime numbers? So we knew 7 could go here. What do you think a 2-digit number that we could make is that only has 2 factors? I use 7. You want to try, somebody said 23. That's a good guess. Is 2 times something going to make 23? Is 2 times something going to be able to make 23? Or is it only 1 times 23? Can I split 23 in half? If you have to, take some pennies or something around your house, grab out 23 of them, see if you can put them in an array or a rectangle in some way in which that it turns into a perfect rectangle. Just like all of those did for 1 times 16 and 2 times 8 made a rectangle and 4 times 4 made a rectangle. See if you can do that around your house. Your job is see if you can make 4 different 2-digit numbers and 1 single-digit prime number. And so that's your goal right now. Go ahead and attack it. All of you in the room, help each other out. See if you can figure this out. All right, we're ready for the second problem on day 3. It's called multiplication strategies, and it says to do these in your head. So you have a whole bunch. You have like 12 different problems to try to do in your head. I don't think we're going to have any problem with this, so let's have some fun with it. So the very first one says 3 times 10, or 3 groups of 10. You can even count by 10 3 times, 10, 20, 30, boom, you got it. 3 groups of 10 equals 30. Let's look at this one a little differently. It is 3 groups of 30, and most of us can count by 30 in our head, but what else can we do with this? Let's take 30 and let's break it apart into 3. Let's break 30 into 3 times 10. Does that still equal 30? So we're going to write this as 3 times 30 is equal to 3 times 3 times 10. 3 times 3 is 9. 9 times 10 is 90. All of these across here are equivalent expressions. Each one of those, this is an equivalent. Whole sentence there is completely equivalent all the way across there. That equals 90. That flexibility is going to help us do things in our head with more complex problems. See if it still works with other things. Let's try 90 times 3. Or I'm going to say it the other way around, 3 times 90. How can we break apart 90 into 2 factors? That's right, 9 times 10. 3 times 9 is 27. 27 tens. If I have 27 tens, I have 270. This one was too easy for you. You probably went to the bathroom while doing this one because you already had it finished. All right, this is one of the easiest ones on here. Take it home. You can look at the very last one. 3 groups of 1 million. How many millions would you have? You guys got this one, no problem. All right, our very last problem for the day, everybody, is we're going to do which one of these does not belong. Now, this has been known to have some altercations because people disagree on which one doesn't belong. There's a little secret to this. Any of these cannot belong depending on your reasoning. So there is not necessarily one right answer. There's a whole bunch of right answers. So as I look up here, the very first one that I think doesn't belong, I'm going to make it like it is on your paper, is 9 plus 1, because it's the only one that has a number that's made of all straight lines. There's no curves. Can you see which number I'm talking about? Although mine's a little jacked up. That one there is all straight lines. So maybe I can say that's why 9 plus 1 doesn't belong. I'm going to try to think of one. I'm going to say this one doesn't belong because both of its addends are identical. Which one do you think I'm thinking of? Both of its addends are the same. Which one do you think I'm thinking of? If you said 5 plus 5, that's right. Keep thinking through. What's a reason? Tell it to your neighbor. What's a reason? What's any reason? Many reasons why 2 plus 8 might not belong. What's a reason 3 plus 9 might not belong? What's a reason another reason why 9 plus 1 might not belong? And then what's another reason why 5 plus 5 might not belong? Any one of those, choose it. We'll see you guys soon.
Look around. Listen. We're moving to a new beat. A colorful symphony, each note made more beautiful by the next. We are driven by talent in the classroom, in each school, that recognizes the potential in every student and knows the opportunity to achieve is not an option, it's expected. We are not alone. We stand among giants, eager to help, eager to give back and build bonds to last generations. We are part of a city fueled by grit, strength, and determination. Racing toward a future full of potential, where hard work really does pay off. When one succeeds, we all succeed. We're innovative, we're industrious, we're imaginative. We are your Indianapolis Public Schools, and we're stronger together.
I think I need to call in sick.
Why? What's wrong?
My throat is sore, dizzy, runny nose.
It sounds like nasopharyngitis.
More than a dozen surprisingly specialized education models to choose from. Explore them all online. Yeah, that's IPS.
What's going on?
I don't know.
Okay, try it now.
Yeah, that's IPS.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Good morning, IPS fifth graders. Mr. Snape from Christian Park Elementary, and I am here to talk about math today. And in our packets, we're going to be doing day 3 in the math packets. But before we get started, I have a question for you. Since we have been home for 6 weeks, what is one service that you miss? For example, getting your hair cut, different things like that. For me, it's getting my hair cut. This is like 6 weeks of growth, and I normally do it after every 3 weeks. I'm thinking about letting my wife cut it for me. What do you guys think? Should I let her? All right, let's get started. Okay, today for math, we're at the first part of day 3, multiplying a decimal by a fraction to get a whole number. So before we actually get started with that and the directions, I'm going to kind of review a couple steps that you'll need to know. Remember, when we convert a decimal to a mixed number, we write it as a mixed number the way we say it. 3 6/10 we write as 3 6/10, 3 with a 6 over the 10. The second thing you'll need to remember is converting a mixed number to an improper fraction. Remember, an improper fraction is a fraction greater than 1, and the numerator is larger than the denominator. We kind of do like a fishhook thing. We take the denominator, multiply it by the whole number, and then add it to the numerator. So 10 times 3 equals 30 plus 6 equals 36, and our denominator stays the same. And then we'll just multiply the fractions. Then at the very end, we're going to change our improper fraction back to a mixed number, and we simply do that by division. Top number in, bottom number out. And like for this one, I did 10 divided by 72, so 10 goes into 72 7 times. I subtract 70 from it. I have a remainder of 2. I know it's a little 2, but I ran out of room. So that 2 now becomes our numerator. The 10 is our denominator. So we've converted this from a decimal to an improper fraction, or a fraction greater than 1, and back to a mixed number. But with the problem that we're going to do today, we're going to have to do the multiplication. Okay, so this is going to be a little bit different of a problem. We're not going to give you a number. You have to use the numbers between 1 and 9, and you can only use them one time. Okay, you cannot use it. You can't like have 3 3/10 because I'll be using the 3 twice. And one other thing that I want you to know, and with this packet we're doing a lot of things differently, you're not always going to get one right answer or a right answer. We're trying to teach you to think critically and to problem solve. Making mistakes is okay. I guarantee you I make plenty of them. So the problem that I'm going to try first off is 3 5/10 times 4 halves, and we're going to see what that equals. Okay, so I'm going to write the first number as a decimal. I'm going to multiply it by 4 halves. And remember, don't say 4 over 2, it's 4 halves. Okay, remember the 2 at the bottom is halves. And we're going to see what the answer is. All right, so back to the first step. What do I have to do with this decimal? I have to change it to an improper fraction first. All right, so I'm going to change that to 3 5/10 times 4 halves. Okay, now back when we've talked about multiplying by fractions, we can't multiply a mixed number. So this is why we have to go down to step 2 and convert it to an improper fraction, or a fraction greater than 1. I'm going to take 10 times 3 and get 30. And then I'm going to add 5 to it, and that's going to give me 35. And my denominator stays the same. And now I'm going to multiply it by 4 halves. Now I can do the work, because when we multiply, remember we just multiply across. Okay, 35 times 4. 35 times 4 is 140, and I can do that by counting by 35s. 35, 70, and go up that way. So that's 140. And then 10 times 2 is 20. Now remember, we talked about that we have to change this back from a mixed number to either from an improper fraction to a mixed number, or hopefully, if we did it right, it'll be a whole number. So I set up my division problem. Top in, that means it goes on the inside of the division symbol, or what we call this sometimes is the house, and the denominator comes on the outside. Okay, so 20, now I know 2 goes into 14 7 times. So I'm guessing that 20 goes into 14 7 times also. So I multiply, 7 times 20, and I get 140. All right, no remainder. My answer is 0. So I have the correct solution. I have, so 3 5/10 times 4 halves equals 7, and I only used one digit one time. Okay. Now what I want you to do is I want you to go through and I want you to try some other problems, because I know for a fact there's at least 2 or 3 other ways that this problem can be solved. Now part 2 of our lesson, this is a problem that you're not going to have to, there's not one right answer. Okay, so we're going to play a little game, which one doesn't belong? And we're going to look at the numbers 3, 27, 123, and 31. All right, so I want you to take a few seconds. I want you to look at that and see if you can figure out which number doesn't belong. Okay, there's multiple choices to this one. I don't think 27 belongs. Okay, so I'm going to write down my number, and then I'm going to write down why it doesn't belong. Okay, 27 doesn't belong because it doesn't have a 3. So if we look, 3, 123, 31, 27 doesn't have a 3. Okay, let's see if I can find something else there. How about the number 3? I don't think the number 3 could not belong because it only has one digit. That's why Mr. Snape teaches math and not English. He can't spell. Or write. So 3 isn't because it only has one digit. And I'll give you one more example, and that is going to be the number 31. Okay? And the reason I chose 31 is because 31 is not a multiple of 3. If I counted by 3s, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and if I kept going, 123 is also a multiple of 3 because 3 times 41 equals 123. So I could write down 31 because it isn't a multiple. Once again, Mr. Snape can't spell. Because it isn't a multiple of 3. Now, on your packet, you're going to have 4 different numbers on yours than what we have up here. So I want you to find as many different reasons that you can find out why a number doesn't belong, and give a reason why. Then the third section of your packet is going to be a story problem. All right, and there's not really a way to teach this how you're going to solve the story problem. So what I'm going to do is a talk aloud, and I'm going to talk about how I would solve this problem. So let's read the problem first. Ronaldo has 10 friends coming over to watch a basketball game. He wants to give each of his friends an equal number of cards, and those would be trading cards. He wants to keep 6 for himself and have none left over. Which pack should he pick? We've got baseball he has 186 cards, he has 191 basketball cards, and he has 237 football cards. Only one of those packs will divide into his 10 friends evenly and keeping 6 for himself. Okay, so I'm looking at those and I'm like, so as I do it, I think, the first thing I'm going to do is I'm going to take out the cards I want to keep first, because then that way it'll be easier for me to decide which pack would be best to give my friends evenly. So let's look at the baseball cards. There's 186 baseball cards. All right. If I keep 6 for myself, so if I want to keep 6 for myself, what operation should I do right here? Give you a second to think about it. Yeah, I should subtract. Okay, and I want to keep 6, so I'm going to subtract 6. So 186 minus 6 equals 180. All right, and let's look at the basketball cards. and there's 191 of them. I want to subtract 6 again from that. So as we look at the basketball cards, we have 191 of them. 191 minus 6 is 185. And then finally, we'll look at the football cards. And there are 237 of them. So I'm going to take the 6 out that I want to keep for myself. And that's 231 cards. Okay, now I got to decide which one of these would be the best cards to give my friends so that each of them give 10. Well, I can use my divisibility rules with this. This is a simple one where I can use, I know that I have 10 friends. All right, got to find out how many cards I need to divide it by. Okay, and since this number ends in 0 and this number ends in 0, they have to go into each other evenly. That's the divisibility rule for 10. If the last digit ends in 0, it has to be divided by 10. Okay, so I'm going to take 18 and divide it, or I'm going to take 10, 180, and divide it by 10. All right, now we also talked about with divisions by powers of 10 that all we have to do is move decimal places. Okay, since we're dividing by 10, that's 1 0. I can move my decimal point back 1 place here, and that's 18. All right, so 10 times 18 is 180. Each friend gets 18 cards. Now you're going to have a little bit different problem, and I think with this one you can use the divisibility rule of 9. And if you remember, the divisibility rule of 9 is if all 3 of the digits add up to be a multiple of 9, then it can be divided by 9. That's today's lesson. I hope that you stay safe, get some time outside in the nice weather if you can. If you have questions, you can always contact your teacher. I know you have ways through school to do that. Have a good day.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Greetings, IPS 5th graders. It is Mr. Snape. I teach at Christian Park Elementary, and I'm here to work on today's math lesson with you today. Today we'll be working out of week 1, day 4. Before we get started, though, I have a question for you. Through the quarantine and the lockdown, what is something that you miss doing that you normally get to do this time of the year? Think about that. If your parents are there with you, if you want to talk with them about it, that'd be great. Mine is baseball. Baseball is my favorite sport. I help coach a couple different teams and get to watch my granddaughters play, and it's really hard not going to baseball games and driving by and see the fields empty. All right, let's get started with today's lesson. Our first lesson that we're going to do today is division, and we're going to do it in 2 different ways. We're going to use partial products, and we're going to use an area model. Okay, you may have done these this year, you may not have. So we're going to start out with our first problem, 240 divided by 15. Now, one of the parts about when we do division problems is we always like, okay, how many times? Okay, so we're going to dump our brain a little bit, and we're going to try to do a little work ahead. Okay, so we're going to make a ratio table. All right, and if you remember what a ratio table is, it compares 2 numbers. So since 15 is the number that we're dividing by, that's going to be down here, and our ratio is going to be 1 to 15. And we can build up our table, and that will help us with the division. So if I use the number 2, 2 times 15, I put my multiplication sign here, 2 times 15 would be 30. Then we'll go to the number 3. 3 times 15 is 45. And we'll do the number 5 because 5 is a multiple. 5 times 15 is 75. I'm going to add 2 more there. We'll bump up to 10. All right, 10 is pretty simple. We know that 10 times 15, we just add a 0, so that's 150. And we'll finish out our ratio table with the number 20. So if we know that 10 times 15, the ratio is 10 to 150, since we doubled 10 from 10 to 20, all we have to do is double this. So we go to 300. Okay? So now let's come over here and